Okay, first of all, our homework. The homework from Friday, what you needed to do was to um, use the fundamental counting principle to find the answers for the first few. Here are your answers. Okay. Please check your work. Okay. For the total number of outcomes for each. Here they are. This is the work that you would need to show, and then the answers. Okay. So let's do these first. For number 5, you needed to not only give me the answer as far as how many choices, but then the probability. So here's that. Okay. And then for the back, here is your tree diagram for the first night, and then the second, and then your outcomes. And then the answer for B is the probability that Bill wins both nights, the same as the probability that Alice wins the first night and Chester wins the second night, is yes, because each has an equal chance of winning both nights. So the answer is yes. Okay. Now, for your assignment today, you are to copy these notes into your binder. Then you are to do spiral 1, which if you haven't done it first, you finish it. Copy these notes, then do the homework. Once you've done all that, you can do one of two things. You can either read or think through math, one or both, one or the other, until the end of the period. Okay, and that would be it. This is a shorter lesson. Okay, so you are going to have time to do one or the other. So if you haven't done your think through math that's due today, make sure that you get that done. Okay, so for this lesson today, okay, here's what we are going to do. In the previous lesson, we introduced tree diagrams, okay, as an effective method of displaying possible outcomes of certain multi-stage chance experiments, okay. Additionally, in such situations, tree diagrams were shown to be helpful for computing probabilities, okay. What we're going to do is we're going to do more of that today, okay. So as you recall, okay, in the one that we did for the board game, okay, if you remember, we did the one for Monday and Tuesday, and here's what that one was, okay. And as you recall, okay, we had a board game. If they selected it, you had a board game between a board game, your choice of a board game, or a card game on Monday, okay. And then on Tuesday, you had that same choice. So here were your possible outcomes for those days, okay. So now when we turn the page, okay, so but how would the diagram change if you're interested in mapping, the possible overall outcomes over 3 consecutive nights, including Wednesday? Well, if you did that, that's how it would look. So again, we would have Wednesday. And remember, each night you have those same choices, okay? So by doing that, here are your choices, okay? And sorry, guys, it's been a long day. I'm doing this on Friday, so bear with me. Okay, so on Wednesday, okay, if you picked a board game on Monday, board game on Tuesday, on Wednesday, you still have that same choice, okay? If you picked a board game on Monday, card game on Tuesday, on Wednesday, you still have that same choice of both things, okay? So then if you list that outcome, you have a board game on Monday, board game on Tuesday, board game on Wednesday, and that takes care of the first one. Or you have a board game on Monday, board game on Tuesday, card game on Wednesday, that would take care of this one, okay? So now in the first exercise down at the bottom, where it's questioning what it's asking here, it says if B, B, and B represents 3 straight nights of board games, what does C, B, B represent? That means the first night is a card game. The second night is a board game. And the third night is a board game. And just like on the board, ladies and gentlemen, Mrs. Smythe does make mistakes, so let me fix that. I'm sure you all have noticed by now that I made that mistake. So let me fix that. Okay. So now it says list all the outcomes where exactly 2 board games were played over 3 days. And how many outcomes were there? Okay. So that would be B, B, C, B, C, B, and C, B, B. And that would be a total of 3 outcomes. Okay. So far, that's what we have. The next are exercises that we have to do. Okay. So the next thing that we have to do is make up a tree diagram on our own. So it says, assume you are trying to put together an outfit to wear to an upcoming event you are planning to attend. You have 3 pairs of pants to choose from. Okay. Labeled P1, P2, and P3. You have 2 tops, T1 and T2, and 2 pairs of shoes, S1 and S2. We want to know how many possible outfits you can make with these 3 clothing items. Well, here's what you want to do. We have, first of all, the pants. So we have P1, P2, and P3. The next thing is the tops. Well, if I pick the first pair of pants, then I have a choice of top 1 and top 2. Well, if I don't pick the first pair of pants, but I pick the second pair, I still have a choice of top 1 and top 2. If I don't pick the second pair, but I pick the third pair, I still have a choice of top 1 and top 2. Now I have to pick my shoes. If I pick the pants from the first pair of pants and the first top, I can pick the first pair of shoes or the second pair of shoes. If I pick the first pair of pants and the second top, I can still pick the first pair of shoes or the second pair of shoes. If I pick the second pair of pants and the first top, I can pick the first pair of shoes and the second pair of shoes. Okay? And this is going to go on throughout the entire tree. So I can pick shoes 1 and shoes 2, kind of like thing 1 and thing 2. So the pants 3, top 1, shoes 1, shoes 2. Pants 3, top 2, shoes 1, and shoes 2. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have a total of 12 outcomes. And we've got to list those. I know, it's a lot. but we still got to list them. So we have P1. Oh, let me fix that. We have P1, T1, and S1. P1, T1, S2. P1, T2, S1. P1, T2, S2. Then we have P2, T1, S1, P2, T2, sorry, T1, S2. We have P2, T2, S1, P2, T2, and S2. That's a mouthful, I'm telling you, it's rough. P3, T1, S1, P3, T1, S2, P3, T2, S1, and P3, T2, and S2. Okay? So that would be our tree diagram and our outcomes. So the next one. If we flip our coin three times, what's the probability of getting exactly 3 heads? Well, we got to do our tree diagram first, okay, because that's showing our work. So the first time, I can get heads or I can get tails. The second time, I can still get heads or tails. If the first time I get tails, the second time I can still get heads or I can get tails. The third time I flip that coin, I can get heads or tails. If I get tails, I can get heads or tails. I can get heads here or tails. And here I can get heads or tails. So a total I have 1, 2, 3, 4, 5, 6, 7, and 8. So I should have a total of 8 outcomes. So I can get heads, heads, and heads. Heads, heads, and tails. Heads, tails, and heads. Heads, tails, and tails. Tails, heads, and heads. Tails, heads, and tails. Tails, tails, and heads. Tails, tails, and tails. So the probability of me getting exactly 3 heads is right here. Or the probability of 3 heads is 1 out of 8. Now, that ends our lesson. If you notice, the next page is your problem set. So from here, you should be working on the few things that I said in the beginning. Your problem set, do the homework. The spiral, if you haven't finished it already. And then do reading or your think through math. Have a good day, gang.